This is a very challenging section, I think, mathematical modeling. It also is one of the most useful. This is where quadratic functions, parabolas, of course we know all parabolas can be described by a quadratic function. This is when they hit the world with something useful with them. It's not easy, however. Although once you know how to do it, you'll be able to do it as well as anyone. This lesson I am going to dedicate to, see if I can get my pen here. Well, I guess I won't have my pen until I plug this thing in. Sorry about that. There we go. Okay, so I had a bit of a false start. Please forgive me. I would like to dedicate this to, now I'll see if I've got my pen yet. I'll work on that. I do. There it is. Whoop, let me put it in the right place. Julia, who is usually about 2 steps ahead of me. She's keeping me on my toes. So this one's to you, Julia. Oh, why don't I talk for a minute about what we're going to do here? We'll find, just given 3 data points, so 3 pairs, x sub 1 and y sub 1, so we'll have 1 point, and then we'll have another point, and if we have a third point, and we know that these points all lie on a parabola, then we can use those 3 points to figure out what the quadratic function is. And of course, once we're able to do that kind of thing, we can solve real problems. This first section, as always, you can skip over it if you feel you want to get right into it. This is intended to reinforce what you had in the previous lesson. The x-intercepts, we want to find those. And let's just draw a a Cartesian plane here. And we'll imagine we've got a parabola on it. And where that graph crosses the x-axis is, those 2 points are the x-intercepts. One of the things we know for sure at an x-intercept is what the value of y is. Yes. In that case, oh, we have no y here. However, we know that f of x is just a way of saying y. We say it differently. This is called functional notation. Function f, which has variable x, which of course it does, here it is, variable x, is equal to 0. So let's do that. We'll say this is equal to 0. If we want to find the x-intercepts, we can do that. Ooh, and I think I'll try factoring. See if I can come up with 2 factors of positive 10 that when I add them together will give me this coefficient of positive 7. Well, I know this. They'll both be positive. What else do I know? Well, there are not really that many different ways to factor 10, are there? Oh, you had it before I did. Now I can use a zero product property, true, to find out what are the values of x when f of x, otherwise known as y, when f of x is equal to 0. And we find that we've got x is equal to minus 5 and x is equal to minus 2. Clearly not the graph I drew here, but one that probably looked more like this. We know it was opening upward because the leading coefficient right here was positive. Means this graph is opening upward. This one, well, all of these are opening upward, aren't they? Because in every case, the coefficient on x squared is positive. Let's try this one. So we're going to say 0 equals got x, and we've got x. We're looking for two coefficients, no, two factors of plus 3 that when we add them together will give us a plus 1. There's no way that is going to happen. So, x-intercepts. Let's see if there will even be any x-intercepts. One of the things we know about x-intercepts is they only happen for real number solutions. We also know that we can use the discriminant, this part right here, from the quadratic formula to figure out whether, let me write that whole thing out, x equals minus b minus b, it's going to be very messy because I didn't plan ahead properly, plus or minus the square root of the discriminant all over 2a. If this discriminant is less than 0, we do not have a real number. If we don't have a real number, we do not have an x-intercept. So let's test it. What is our b? That's right, it's 1. What is our a? Also 1. And what is our c? That's right, all positive. Positive 1, positive 1, positive 3. So b squared is 1 square, or 1. A times c is 1 times 3, or 3, times a negative 4. So the discriminant is less than 0. There are no x-intercepts here because the solutions are not real numbers. If I were going to graph this, I actually don't know where it is. I should find out perhaps. But one thing I do know is that it does not cross this x-axis. Okay, let's try this one. Oh, maybe I'll go straight to the discriminant this time. We know that our b is equal to 1, our a is equal to 1, and our c is equal to negative 1. So if I take a look at this discriminant, I've got b squared, 1, a times c 1 times negative 1 is negative 1. Negative 1 times negative 4 gives me positive 4. So I have a positive discriminant. Let's use the quadratic formula to solve this. X is equal to negative b, so it's going to be negative 1, plus or minus the square root of the discriminant, which we already calculated, and it's over 2 times a. That's actually where we find our x-intercepts. Now, that's a very messy looking number. If you actually wanted to graph this, what would you do? You'd figure out the decimal equivalent for the square root of 5 and then calculate each of these x-intercepts. I'm not going to take the time to do that right now. If you would like to pause this and go ahead and do it, go ahead. We're going to start into mathematical modeling using quadratic functions and fitting a function to data. If I have a quadratic function f, and I know that at 0, in other words, when x equals 0, if I know when x is 0, I should write that down, that the function is equal to 5, I'm saying y is equal to 5. What do I know about c? Okay, so I'm going to say my function f, when x is 0, right? Instead of putting in x, I put in a 0. That's all equal to 5. So I can do this. 5 equals a times 0 squared. 0 squared is 0. Anything times 0, we don't have to know what a is to know that it's equal to 0. Same thing here. X is equal to 0, so another 0. Oh, that was a tricky question, wasn't it? C has to be equal to 5. So there are ways, if you know a couple points, well, actually, if you know all 3 points or something else about the function, you can start to put that function together. In this case, I knew 1 point. I knew this point, 0 and 5. And with that, I could figure out what c would be in my quadratic function f. Are there 3 points that cannot be fit by a quadratic equation? Ordinarily, we can find a quadratic function to fit any curve if we know 3 data points. That's the key. So if we had 3 points that lay, along a perfectly straight line, those cannot. So if they are straight or lie on a straight line, what did we call those points? Do you remember that from geometry? Did that jump to mind? That's what they are. When they lie on a straight line, and I probably can't draw this, no. I tried to draw a straight line, I get a curved line. But if I had a straight line with 3 points on it, I could never fit that to a quadratic function. Can't be done. It has to be a curve. Okay, so if we have 3 points, 0, 0, x is equal to 0, y is equal to 0, then when x is equal to 1, y is equal to 0 again. When x is equal to negative 1, y is equal to 1, I've got those 3 points. I have 3 unknowns. I do not know what A is, I don't know what B is, and I don't know what C is. We just saw that we could figure out C if we knew that x was 0, didn't we? Well, let's see what happens here. Our unknowns, we've got 3 unknowns, and we've got 3 points. We're going to put those 3 points into the standard equation for quadratic. 3 unknowns, 3 equations. We will be able to solve this. This first point, my y value, f of x, my y value is 0. My x value over here is also 0. That's my first equation. I'm going to like this in just a minute. The next one also has a y of 0, but the x is 1. So I put that in. Notice where x is, right here and here. That's where I put in my values for x. And finally, the third point that lies on this quadratic functions graph, my y is 1, so I put that in for f of x. And my x is negative 1. Now here's where things are going to get really nice, because I'm going to rewrite these working with these numbers. What do we know about 0 squared? It becomes 0. And anything multiplied by 0 is itself right. So we start right off with knowing what C is. C is equal to 0. Well, another way you could look at this, you could say, wow, this, when y is equal to 0, what am I looking at here? I'm looking at my x-intercept. And over here, I'm looking at x-intercept and a y-intercept. That may not be obvious to you, but if we won't graph it either, but if we did graph it, you would see it. So my first equation turns out to be C equals 0. My next equation, 1 squared times A, is simply going to be A. And B times 1 is simply going to be plus B, and C. And that's all equal to 0. Then I have negative 1 squared. If I square negative 1, that's right, I get a positive 1. So again, I've just got A. And negative 1 times B gives me, instead of a plus B now, I have a negative B. Nothing's happening with C. And that is equal to 1. I could, right now, substitute in for all my C's here, this one. I know that C is equal to 0. So I can substitute in C and get A plus B equals 0, and A minus B equals 1. Now I have a system of equations. I had a system of 3 equations here. I have substituted in the value for c, giving myself a system of equations here which only has two variables. This is more familiar to us. What can I do? I can add these two together. And when I do, I'm going to be eliminating one of my variables. Which one is going to disappear? That's right. If I add together a positive b and a negative b, I'm getting 0. So I'll end up with 2a equals, when I add these two together, 1. So what must a be equal to? A is equal to 1/2. I'm not very far from figuring out what b is. I'm going to go to this second equation. A, which is 1/2, plus b, which I do not know, plus c, which is 0, equals 0. Let's subtract 1/2 from both sides. So my b is negative 1/2. This is wonderful. I now know what my function is. Function f of x equals, what's my coefficient for x squared? It's right up here. 1/2 x squared. What's my coefficient for my linear term x? It's b, which I found was negative, so negative 1/2 x. And then what's my constant? Easiest thing of all, 0. I'm not going to write that. There. Mathematical modeling. Fitting a quadratic function using 3 points. It's a very advanced activity. Now we're actually going to do some modeling. Here's a ball going to be thrown into the air. We have the knowledge that it's going to follow a parabolic path. You probably know this from earlier years in math. So any parabolic path can be modeled with a quadratic function. So we can use this. We're going to call this function h. And we're going to say this function h uses time as its input, which we're referring to as t. And here we have t squared plus t plus, and then we don't know what our coefficients are. Same problem we had back here, but with different numbers. We don't know the coefficient of x squared, the coefficient of our linear term x, or the constant. We're about to find them out. We have 3 points that this parabolic path, or the path of the ball, goes through. 0, 6, so this is an x, right? And this is a y. Oh, we're not using x and y, are we? So we're going to use t, and we'll call it h. Okay. So the equation, what does it look like? Well, for our function's value at 0, say 6 equals a times 0 squared plus b times 0 plus c. Our next point tells us that the function is worth 22, so I'm going to put 22 here. And that's when, let's see, we've got t squared, which would be 1 squared, plus b times 1, plus c. And finally, we have an output of 6 again. And now our t is 2 squared, plus b times 2 plus c. I'm going to simplify that over here. This one I love because what's happening with these zeros, these get zeroed, and I end up with c equals, equals 6. This next equation, I'm going to have 1a plus 1b plus c equals 22. So a plus b plus c equals 22. And finally, 2 squared, that's right, so we have 4a plus b times 2, we always write this as 2b, plus c is equal to 6. Now, again, I'm so fortunate. This doesn't always happen. We've been lucky with these last two. C is equal to 6, so I can rewrite this with a 6 in here. So let me do that. I'll say A plus B plus 6 equals 22. This one, 4A plus 2B plus 6 equals 6. Now that can be simplified before I try solving this. I'm going to subtract 6 from both sides. We'll have A plus B equals 16. And we'll have 4A plus 2B equals 0. Now, if I were to multiply this equation here, well, I'm going to change my color for a moment. It'll be easier for you to follow if I go to a different color. And I'll pull this down. If I multiply this by a -2, everything inside here by a -2, this will become a -2b. When I add them together, then I'll get rid of my b. Remember, when we're solving systems of equations, our goal is to eliminate variables until we're down to 1. So let me rewrite this. I've got a -2a, a -2b. I'm going to multiply 16 by -2. This equation here I'm going to leave alone. I'm going to take both of these and we can add. All right, so we add these together. When I do, I'm going to eliminate the b's. I have a -2 of them and +2 of them. When I add them together, become 0. -2a and a +4a. So a is equal to negative 16. So I'm going to go back and I'm going to figure out, let's use this equation right here because it looks the easiest for me to use. I'm going to put in my negative 16. Oh, wait a second, that's not the easiest one for me to use. The easiest one for me to use would be that one, because I've already incorporated the c. So I'll have negative 16, remember I'm using this red one here, plus b equals 16. I want to figure out what b is. So I add 16 to both sides. B is equal to 32. Some of you already knew that because you remembered what that equation is. Let me pull this up here. So now I'm going to put in my A, B, and C. My equation will then read like this. Function h of t is equal to, my A is negative 16, negative 16 t squared plus 32 t, right? That's my B, times t, plus 6. There you go. Now we're already at half an hour. Let me see what I've got ahead of us. One more problem. I'll tell you what, if you feel like sticking with me for this, go ahead. But you've actually done your duty. We're at 32 minutes already. I just love this stuff. So consider this just extra, in case you're interested. A solar heating device requires a parabolic reflector. So that's, part of a parabola. The design requires that the parabolic cross-section go through these points. Find the quadratic function that contains these points. All right, so I know that every quadratic function, this one is going to be function f of x, looks like this. Some number times a squared plus some number times x squared plus some number times x, and then a constant. Well, using this first point, here's the value of the function, 2. A times x squared is going to be negative 1 squared plus b times negative 1 plus c, which doesn't have an x on it. My next point, the value of the function at 0 is 0. So I'm going to say a times 0 squared, and you're probably wondering why I even bother doing this, because we know where we're headed with it, right? 0 squared. Yeah, I'm just going to do it anyway. You might forget that that's a negative. I don't make that clearer. And my third point, its value, the value of this function we're looking for, is 1 when x is 1. So this is 1. All right, kind of a mess. I'm going to change colors, and we'll go over here and try writing this a little neater. When I square a negative 1, I get a positive 1, so that's going to be a with a positive 1 on it. This is going to be negative b plus c equals 2. This equation, what happens here? This is zeroed. So we get this zeroed. We end up with c equals 0. This equation is going to be 1a plus 1b plus c equals 1. A plus b plus c equals 1. Now I told you it doesn't always happen that we can figure out what c is right off. And now I've had 3 examples in a row where that happened. Believe me, we're just lucky. So I'm going to incorporate that right now. C is equal to 0, so I'm going to rewrite that with that information in here. A minus b equals 2 because c is 0. And my third equation, a plus b equals 1. Now I'm so fortunate I can just add these two, and I get 2a, my b's cancel out, equals 3. So my a is equal to 3/2. My b, let's figure it out. I'm going to use, I'll change color. I'll use this equation. It looks like it might be the easiest one to use. 3/2 plus b equals 1. I'm going to subtract 3/2 from both sides. I'm going to get b equals, 1 is how many halves? 2 halves. So I've got 2 halves minus 3 halves giving me a negative 1/2. So what does this equation look like? It's f of x equals a times x squared, and my a is 3/2 times x squared. My b is the coefficient of x, and my b is minus 1/2 x. And my c, I don't have to bother writing because it's a 0. For those of you who are still with me, thank you so much. I do appreciate it. We are done.